Crash Course Instrumentation, Episode 36, The Money Analogy for Voltage, Current, and Resistance. In this episode, we're going to reframe Ohm's law through one of the most relatable lenses possible, money. That's right, electrons as dollars, and your circuit as an economy. Why analogies work. Technical explanations are great, but analogies help concepts stick. If you can relate voltage, current, and resistance to money, you're more likely to understand and apply Ohm's law. Voltage = budget, how much you can spend. Think of voltage as your available cash. A 9-volt battery means you have 9 volts, or $9, to spend in the circuit. The total voltage is your energy budget. Current = spending rate, how fast you spend it. Current is how quickly the money is being spent. Measured in amperes, it represents the flow of money through the system. A high current means you're spending money fast. Lots of electrons are moving. Resistance equals prices, what things cost. Resistance is the cost of goods in your circuit economy. If a resistor costs 1 ohm, it's like buying a cheap item. If it costs 1,000 ohms, you're getting something expensive. The more resistance, the less you can buy, or the slower you can spend. Putting it together. If the voltage is high, big budget, and resistance is low, cheap prices, you'll get a high current, spending quickly. And if voltage is low or resistance is high, the current drops. You're either broke or things are too expensive. Economic graphing tip. If you graph current versus voltage for a fixed resistance, the line is straight. The slope is 1R, just like a simple budget chart. More money in equals more purchasing power, but only if prices stay the same. Series circuits? Budget split. If you have a series circuit, each component gets a share of the budget. That's called a voltage drop. The more resistance a component has, the more of the budget it uses up. A real-world view. Sensors are often current-driven. The more energy you give them, the more they output. Light bulbs convert your energy budget into heat and light. And resistors are like controlled taxes. They consume voltage without doing useful work. Historical context. In the early 20th century, as electricity spread through cities and factories, educators needed new ways to explain these invisible forces. Analogies were the answer. From water pipes to money, teachers used relatable systems to describe how electrons behave. The money analogy became especially popular during the electrical boom of the 1930s and 40s, when electricity was still considered almost magical by the public. Explaining energy as something you could spend helped connect abstract math to daily life. Even today, this analogy is used in first-year engineering texts and trade training programs. Many of the pioneers in electrical education, like Charles Steinmetz and Edwin Houston, used everyday metaphors in their public lectures and textbooks to popularize electrical thinking. Technician takeaway. This analogy works best when visualizing power distribution across a circuit. Always ask, where is the energy budget coming from? And what's consuming it? And are you getting your money's worth? Next time, we're talking Joule's law, how energy turns into heat, and why resistors burn out when you overdraw your circuit credit. Like, share, and subscribe to keep this energy flowing with Crash Course Instrumentation.